Hello everyone, welcome to Cloud World. My name is Santiago. So on today's video, following the Azure series, we are going to be working with Azure Functions, and today's lesson is going to be the one-on-one. So for today, we will be talking about what are the Azure Functions. We are going to have a highlight overlay of the things that you can do with Azure Functions. We are going to talk a little bit about the hosting options. This is actually pretty important to understand, so you know how you can host your Azure function in Azure and what would that mean for your billing and the usage of your application. From there, we are going to explore what are triggers, inputs, and outputs. These three pieces are actually the most important pieces when writing Azure functions because you will need to provide those in order to make your function meaningless. So let's start with this session today. So the Azure Function is a serverless solution that allows you to write less code, maintain less infrastructure, and save on cost. Instead of worrying about deploying and maintaining services, the cloud infrastructure provides all of today's resources needed to keep your applications running. So this is the huge advantage of working with serverless. You can forget about managing any servers, creating VMs, or creating any type of resources, or allocating a CPU or memory or anything like that. Serverless, it means that your code is going to be executed against a server that you don't have to manage at all. And Azure is going to take care of scaling your function, moving your code throughout the servers and execute it by demand. And also is going to give you the compute power and memory required in order to execute your code. One of the huge advantages that Azure Functions offer is that you can easily integrate those with different Azure services. As a very quick example on a screen, you could have a use case where a user uploads a file into the Azure storage account. In case you don't know what it is, the Azure storage account is just a permanent storage that has multiple services, and one of those services is storing blobs or files into it. So when the user decides to send a file to the Azure storage account, you can integrate an Azure function that reacts to that event. Now think about the same scenario for several Azure services. You could have integration with Azure Service Bus, you can have integration with Event Hubs, with Event Grid and SQL Server, and many others that we will explore in the next video when we create our first function, and we will explore the different type of inputs that we can have. And from there you can write your Azure function to do whatever you need to with the input that it gets. With that, we need to speak about the hosting options, because even when we speak about having a serverless code, there are things that you need to take into consideration. In this case, the most important piece, it will be the hosting of options that we will choose. As you can see on the screen, we have different flavors, in this case 5 flavors, and those flavors are going to support some things and maybe some others, and one of these plans could be more expensive than the other ones, and that will vary according to the requirements of your business. For example, in the consumption plan, you pay only for the compute resources when your function is running. So that means when your function is actually running, you will be paying for that infrastructure and that execution time. If your function is not being executed at all, you don't have to pay for anything. So that is a huge advantage of the consumption plan. On the other side, you could have the flex consumption plan. This is actually pretty similar, but it's going to give you the advantage when you can choose between different compute options. So in this case, you will choose how many CPU and RAM you would like to use. And also you will have the capability to set up things like the virtual network and also manage some part of the configuration for your Azure function internally in Azure. So this will give you more flexibility in terms of managing the hosting of your Azure function. But it's going to require for you to select, say, the proper resources that you will require in order to execute your workload. On the other hand, we have the premium plan, and this is one of the most strongest pieces that we have for the Azure function, because it automatically escalates based on demand. And one of the things that you need to keep in mind with the two previous is that when your function is not being used at all, it's going to a call state. That means your Azure function goes to something that we could also name the sleeping state. So if a user makes a request to the Azure function and the function is in a sleep state, it will take a couple of milliseconds or maybe a couple of seconds to spin up and start the processing. So of course that is going to cause a delay. So if you in your use case you don't want to pay for that delays, a premium plan is exactly what you need to, because it provides pre-warm up. So that means the Azure function will be always available, and the delay time will be almost zero in this case. So this is actually pretty nice. So this also gives you more CPU and more memory options provided by the standard consumption plans. And also you will have the capability to execute your function for a longer period. One of the things also to keep in mind is that Azure Function will have a timeout based on the base plan that you choose to. And if you are looking for a function that needs to execute longer than the standard ones, the premium plan will be a good option for you. Then we have the dedicated plan. And in this case, things change a little bit because you will have the capability to use a Azure function, but you can choose an app service plan in order to execute your function. So in this case, you will have to create an app service plan, which is going to be contemplated in choosing a size of VN and managing how many replicas you would like to have of those VNs, if you actually want to escalate automatically to some certain level or not. So that is going to give an extra overhead to you because you will need to manage that part of the infrastructure by yourself. So taking that into consideration. And the final piece, we have the container apps. This is one of the more recent options that you could choose from. And that means you can deploy your Azure function as part of the Azure Container Apps. That is something extra because the Azure Container Apps is another service, so you can write your Azure function and containerize those and deploy it as part of the Azure Function Apps. And in case you are wondering, yes, you can deploy those into a Kubernetes cluster as well in case you want to manage things a little bit more. So they will give you some extra capabilities that the standard Azure function doesn't have by default. Like for example, managing all the infrastructure by yourself in a more seamless way. And also you will have access to GPUs, for example, to make a graphic processing or parallel programming that requires high demand. You can take advantage of having those into the container environment. With that in hand, just be careful that based on the plan, you will have to choose properly what you would like to take advantage from. Because let's say that, for example, you need a function that have an unlimited amount of time to execute its code, you will be well served by using another plan that is different than the consumption plan, because that will be constrained to 10 minutes. So taking into account those kind of considerations. Okay, so let's talk about the most important pieces that you need to define when you write an Azure function. So let's start with the triggers. So the triggers is going to be that piece of the Azure function that is going to tell to the code what is actually the source of the event and what it actually needs to do. Something very important that you have to take into consideration also with Azure function is that you can define your functions in two ways. You can do it fully programmatically in for example, in programming languages like C#, taking advantage of the .NET framework. And the other option is creating a host JSON file in order to define those things manually using JSON data notation. So if you would like to translate this, you can see that using C# we have an HTTP trigger defining here, and we also have a typing here. So we are translating those into different types. So as you can see, we can specify the verbs, and something pretty important we can say is that the direction. In this case, this will be the input parameter of our Azure function. So in this example, when the user makes a request to this Azure function, of course, as the name suggested, it's going to be through an HTTP protocol and could be in the get post verbs. So this is going to execute some code, and that's one of the options that you can do. The host JSON version is actually more seamlessly to do in cases when you would like to only interact directly between Azure services. As an example, you can receive an HTTP trigger and you would like to send that request into Cosmos DB as an example. So you don't have to write many code in the middle. If you actually need to have some custom code and some custom logic in here, you will be best served using a programming language. So as I was mentioning before, let's say a more clear example of an input. So in this case, we have the different bindings that we can set up throughout the code. And in this case, we have an input. In this case, it's going to be a queue trigger, the input that we have. So that means the Azure function defining the host JSON in this case is going to react into an event that comes from a queue store in a queue from a storage account. If we take a look into the right, throughout the programmatic version, we have another example. In this case, we have an input from a service bus in this case, and this is listening into a topic on a particular subscription, as you can see. So the inputs will be the message that we receive throughout the request and the action that got throughout that message. And from here, you can do whatever you need to with the message. So that defines the inputs. The input is what service is generating the request and what information travels through it. So as you can see, taking different Azure services, you can integrate almost flawlessly those requests into the Azure Functions. Service Bus and QS Storage are two particular examples that we can follow up in here. At the same level, as the same level that you have input, you could also have outputs that the Azure function could write. Let's take a look at this example in the host JSON first. So in this case, this is a queue trigger as the previous example, and when the message gets throughout this Azure function, is going to send the request into a table that is named person and is located also in the same storage account. And this is going to be a table binding that the type is of type of table and the direction is output. So if you translate this into a more simple word, it means that the object that comes from the queue trigger is going to execute the Azure function, and that result will be saved and will be sent and saved and stored in a table on a storage account. Pretty simple. If we go to the left, we have the programmatic version. In this case, we are also getting the item from the queue using a queue trigger in this case, and we are then sending the output parameter in here as part of the new table in here. So as you can see, we can define very basic option in here just to send out the object into an output. So how do you know this is an output? Because also using programmatic language, you say that you are going to be returning an object of type table, setting up the string connection to connect to that table in the storage account, and whatever you return in your Azure function is going to be sent into that output. So in summary, we can say we have inputs parameter, we have bindings that define those inputs and outputs, and that is going to define what our Azure function does. So of course, any Azure function will need to have an input parameter, which is going to bind into the Azure function, and that could be an HTTP trigger or an event generated by another Azure service. The outputs are actually not required or mandatory in this case. They are optional if your use case actually needed to, but you can easily take advantage of those outputs to send messages to other services and take action from them. So from that, we covered the basic definitions from an Azure function, the inputs and outputs and everything that we need to understand, and we managed to understand that the Azure function is a serverless function. So on the next video, we will be creating our first Azure function using the Azure CLI, and we are going to see a couple of examples of different bindings that we can use in order to react to Azure function events. So thank you for joining me on this video today, and see you in the next one.